Hey physics students, this is Miss Bala. I wanted to record a short video on some of the fundamental concepts of the egg drop. Okay, so to start with, just as the name of the project tells you, it is egg drop, which means a structure that contains the egg is going to be dropped. The term drop means your starting velocity is zero. So you're not throwing the structure or the egg, you're just dropping it. So it starts from rest and falls. So now there are a couple of things to discuss while it is falling. So I have just I'm just looking at two sample structures. This is the first one does not have a parachute. The second one does have a parachute. So what's the difference between having a parachute and not having one? So if you look at the first structure, if you draw a free body diagram, the only force on the structure is going to be just gravity. There is a resistance, but not much. But if you look at the second structure, because of the parachute, there is considerable air resistance, which is not negligible. So when you draw the free body diagram, you would represent two forces, gravity and a resistance, which is going to be acting opposite to motion. That's why it's called resistance. And that's going to be upward. So the net force is the difference between these two forces, as these forces are in the opposite direction. So naturally, the net force here will be smaller than the net force in the first case. And since we know that acceleration is net force divided by the mass, again, the acceleration here will be smaller than the acceleration here. Here the acceleration is simply 9.8 meters per second squared for the first structure because it is in free fall. The second one with the parachute is not in free fall, so its acceleration will be less than 9.8. Okay, so if both are falling from the same height, since this has a higher acceleration, when it hits the ground here, it will have a higher velocity. This one has a smaller acceleration, this one will hit with a smaller velocity. In reality, the air resistance is not a constant force. It is dependent on the speed with which the object is moving. So what happens in reality when any object falls down is this. As the speed of the object increases, the air resistance also increases. So at some point of time, the air resistance matches up to gravity. And when this happens, you know that these two vectors are equal and opposite. They can cancel each other out, making the net force zero, and therefore the acceleration zero at this point of time. So when this happens, when the acceleration becomes zero, then whatever speed it has at that moment, it will just keep drifting down at that same speed or the constant speed. And that constant speed is what we call as terminal velocity. It's unlikely that your egg structure will reach a terminal velocity if you drop it from 2 meters or 1 meter, because air resistance may not increase enough to cancel out gravity. But if you have a very light structure and a very effective parachute and you drop it from a considerable height, it is likely then it will reach a terminal velocity before it hits the ground. Okay. So now coming to deciding how the egg can be kept safe, that is determined by the impact force. The impact force is the force that it suffers when it hits the ground and then comes to a stop. So this force has nothing to do with the net force during the fall. That is different. The impact force is the force which the ground applies in order to bring it to rest, right? So to calculate this impact force, you can use the formula. Force is change in momentum, or otherwise called as impulse over time. And we know that impulse can be expanded as mass times final velocity minus initial velocity divided by time. So this is just for impact. And so the velocity with which it hits, that is the final velocity from free fall, now becomes the starting velocity for the impact, because it hits with a certain velocity and then comes to rest. So here the final is 0 and this becomes our initial. Okay, so since the final is going to be 0, we can cancel this out. So that means your impact force depends on three factors. What is the mass of the structure? What is the velocity with which it hits the ground? And how much time does it take to stop? So if the mass is higher, then the force is also going to be higher. If the speed with which it hits the ground is higher, that means the force will also be higher. Okay, so that is why having a parachute helps, because it will hit the ground with a smaller speed and therefore the force can be smaller as well. What about the time of impact? So we do not have an estimate about the time it takes to stop when it hits the ground, but here is the thing that you want to consider. Even though in this structure will hit the ground and stop quickly if all of this bottom portion is made up of foam or a material that has some kind of a give. Then even though the structure stops quickly, the egg will just kind of sink into this cushion and slowly stop. That is like as though you dropped the egg in some sort of a foam bed, let us say. When it hits here, it is not going to stop here. It's going to sink and make a depression into the foam bed and slowly stop. So that increases the time of impact. So wherever there is a cushion or a padding to the egg, that increases the stopping time for the egg. And so then going back to our formula, so if this time increases, what will happen to the force? Because it's in the denominator, the force will decrease. So all these three things will decide how heavy the object is or the structure is. That decides the force. What is the speed with which the structure hits the ground? That is going to decide the force again. And then how much time does the egg inside of the structure take to stop? And that will decide the force on the egg. Okay. Hopefully this will help you answer all the questions, and this will also help you answer questions on the TBA as well as on the project. And if you have any questions, feel free to reach out to me.